Hello everyone, Mr. Azeez Maths. In this video we're going to prove three trigonometric identities. The first one that I'm going to start with is this one. Tan x plus 1 over sine x tan x plus cosine x is equivalent to sine x cosine x. So to prove, we start with the side that has more terms because we have more works to do. In this question, we have the left-hand side is the side that has more terms. So we start with left-hand side. We take this side, we simplify it until we get the right-hand side. So instead of tan x, I'm going to write sine over cosine. Sine over cosine plus 1, and this is sine x. Instead of this tan, I'm going to write sine over cosine as well. So if you wonder why I didn't simplify these two tans together in the first place, the answer is we cannot simplify when there is plus or minus next to a term. So this tan is next to a plus, then we cannot simplify this tan. The same thing is applying for this one. This tan is also next to a plus, then we cannot simplify them. In order to simplify, none of them should be next to a plus or minus. Now we have plus cosine x. Okay, since we have fraction here and another fraction here, let's find common denominators. So 1, instead of 1, I'm going to write cosine over cosine because 1 is equal to cosine over cosine. Actually, when we have the same term for a fraction, it is equal to 1. So instead of 1, I'm going to write cosine over cosine instead of this one. And for these two, I'm going to find the common denominator, which is cosine. And then since this term has no denominator, I wrote a denominator for it, which is cosine. Then I'm going to write the same denominator here next to the term. Because if any time we simplify these two cosines together, we'll get the original term back. Now let's rewrite what we have. Instead of 1, we have cosine over cosine. Let's just write this. Sine x over cosine x plus cosine x over cosine x all over. When we multiply a term by a fraction, we just multiply it with the numerator. Then in this case, we have sine times sine. Sine times sine is sine squared. So sine squared x over cosine x plus cosine times cosine is cosine squared x over cosine x. Now we are able to add the fractions because they have common denominator. It's equal to sine plus cosine over cosine x. These two denominators became 1 to make it simpler. Then sine square plus cosine square. We all know sine square plus cosine square is equal to 1. So I'm going to write 1 instead of sine square plus cosine square. And the denominator of this is cosine x. Now I have a fraction here and another fraction under. So the two denominators can cancel each other because they are the same. Then finally, what's remaining is sine x plus cosine x over 1, which is just sine x plus cosine x. And if we look at this and here, this is the right hand side, and that's how we stop. We started with the left hand side. We went step by step. Everything is related to either rule or identity. Finally, we got the right hand side, and we stop. We don't simplify anymore. The next trigonometric identity that I'm going to prove is this. 2 bracket 2 1 plus cosine x minus 1 plus cosine x squared is equivalent to sine squared x. Okay, again we start with the left hand side because we have more terms here. It means we have more simplification. We start with left hand side. We can straight away expand the brackets when we write left hand side, or we can copy left hand side, then the step after simplify. So to have to spend less time, I'm straight away expanding. 2 times 1 is 2 plus 2 times cosine x will be 2 cosine x. I have minus with a square bracket. I keep the minus. I write a bracket like this. After I expand this, then I multiply this minus by inside the bracket. We have a squared brackets. The quick way is like this. Listen carefully. The first term squared. So this is 1 squared. 2 times first times second. 2 times 1 is 2. Times the second term, it will be 2 cosine x. This way works all the time. And finally, the second term squared. So it will be plus cosine squared x. Close this bracket. I'm going to say this again. First term squared. 2 times first times second. Depends on the sign of the first and second to say plus or minus. First squared. 2 times first times second. Second squared. Now this minus will change all the signs here. Let's copy this. 2 plus 2 cosine x minus 1 minus 2 cosine x minus cosine squared x. Now negative 2 cosine x will cancel positive 2 cosine x, and 2 minus 1 is equal to 1. 1 is remaining. Negative cosine squared is remaining. And according to rule, 1 minus cosine squared x is equal to sine squared x. And sine squared x is the right hand side. So that was an easy one. And the third one, why I chose these 3, it's based on my subscribers' questions. Someone sent me these 3 and I'm proving them. The last one, it's the easiest one, you will see. It says tan squared x plus 1 is equivalent to 1 over cosine squared x. Okay, which side to start with? Again, the left side is easier because tan will be sine over cosine plus 1. Then we can replace this 1 by something we need based on the tan squared. And finally, we need to get 1 over sine squared x. So firstly, starting with the left hand side, tan squared x plus 1. Tan squared, we can rewrite it as sine over cosine. The tan squared, the sine and cosine are also squared. Plus 1. Then I can replace 1 as a fraction because I have a fraction next to the 1. The denominator of the fraction is cosine squared. So I say instead of 1, I write cosine squared over cosine squared. If I simplify, I'll get the 1 back, so there's no problem. Now I just replace 1 by cosine squared x over cosine squared x. You can always do this. You can replace 1 by a fraction if it's next to a fraction, and you can write the denominator duplicated up and down, then good to go. Sine squared x over cosine squared x plus cosine squared x over cosine squared x. Then they have same denominator. I can add the numerators, and the numerators are sine and cosine squared. So sine squared plus cosine squared is equal to 1. It's ruled. And the denominator is just cosine squared x. If we look at this, and the right hand side in the question, we see they are the same thing. So we just state here, right hand side. Finish. I hope the video is helpful. Thank you for watching. Don't hesitate to forward your questions to me, and I'll make videos like this to explain.